Good morning. Welcome to today's storage stream, first of 3 sessions. And for this first session, I'd like to welcome Simon Dawn from Hitachi Vantara. It's good to see Hitachi Vantara at GSE, and Simon has an update on the VSP5000. So Simon, over to you.
Thank you. So hello everybody. As say, we will talk today about what's new around our VSP5000 series. As proposed by the GSE, please consider doing something to those two associations. Our agenda today will be some explanation about what's new around our VSP5000 series. You may be aware about that, but those 5000 series are our high-end solution. We will present something new by Hitachi Vantara called Modern Storage Assurance. After that, we will discuss around what we are doing and what's new around our mainframe features. And at the end, we will discuss about our synergy with IBM OS and one example of a partnership we have with some other companies. So what's new our VSP5000 series? Our VSP5000 has been released at the end of year 2019. So it's a brand new architecture that can be end-to-end NVMe for open system, and we are using those NVMe capabilities to increase parallelism and to reach really high performances. This VSP5000 is available for open system and for mainframe systems, and we can handle both workload on the same box. It's a scale-up and scale-out architecture. We will discuss about that later. And at the end of 2019, when we first released this VSP5000 series, there was two models in this family, the 5100 and the 5500. And at the end of October this year, we have released 2 new models in this VSP5000 family. So it's the VSP5200 and the VSP5600. It's a kind of midlife refresh to increase the power of the embedded controller of these systems. So if we had a look in the past, this is the architecture of our previous high-end solution. So it was called the VSP G or F 1500. It was a kind of symmetric shared multiprocessor architecture. Customer has the choice to start with one controller and add multiple front-end cards or back-end cards and compute cards depending on the needs. In case of biggest I/O performance requirement, the customer has the choice to add another controller with some other I/O cards. And in this architecture, there was always at least 2 physical paths to reach a cache slot in the system, for example. And the new VSP5000 is completely different because that's the architecture of this new system. So it comes with a quad controller block composed of 2 nodes, one node here and one node here. And in each node, we have 2 controllers with front-end cards, back-end cards, compute and memory. And what's really new in this new architecture, that is a by 4 architecture. It means that at any time there is 4 physical independent paths between 2 controllers. So if a controller has to reach a remote data host owned by another controller, it can be that through 4 different paths. So if we look at the left of this chart, we see that in each quad controller block, we have 2 HA nodes. And something that is really special with this architecture is that the interconnection between those nodes is done by what we call an Hitachi accelerated flash fabric. So an accelerated flash fabric is something patterned by Hitachi, who is made of PCI Express fabrics plus some FPGA to assist communication between controllers. So we are using those dedicated FPGA to avoid interrupting remote CPU when we have to do some cross IOs, for example. And with this architecture, we reach this really high availability of 8 nines. So that's something new in kind of high-end storage. So what's new with the VSP52 and 5600 announced last month? We replace the CPU of the previous version by some new controller, some new CPUs. So before, with the 51 and 5500, it was Broadwell, Intel Broadwell CPU. And now with our 52 and 56, it's Cascade Lake CPU. And something really new that has been added to those new VSP5000, but that is only usable for open workload, is those ACLF. So ACLF, it's a kind of compression accelerator module. So we added some dedicated hardware to offload the compression that was done before by the CPU. So it allows us to reach really high performances and to free a lot of CPU cycles to deal with the IOs. Unfortunately, compression is not available for mainframe customers. So as said before, in this new VSP52 and 5600, we have Cascade Lake CPU instead of Broadwell in the previous version. We have improved our power to lower the consumption of the system and to reach a more efficiency. So now we are using platinum rated power system. And we have some new cache flash modules. So those cache flash modules are used to offload the cache in case of a power outage, for example. And of course, what is completely new is those compression accelerator module. So that's those dedicated piece of hardware that deal with the compression. So why are we talking about scale up and scale out architecture? So it's quite simple. It's because the smallest system in our VSP family is the VSP5200. So this system came with 2 nodes, but in each node there is only 1 controller. So it's a kind of 2 controllers system. We can upgrade it to reach a VSP5600. We called a 2-node system. So in this 2-node system, we have 2 different nodes with 2 controllers in each one. So it's a 4-controller system. And same here with 2 additional nodes to reach a 4 nodes and 8 controller systems. And same with 6 nodes and 12 controllers. So here that's the biggest VSP 5000 that we can provide today. As we will see later, we can choose and we can intermix backend between NVMe and SAS. We allow customer to disperse all those components up to 100 meters between those components. Of course, it's available for mainframe and for open workload. And we do support data in place upgrade to modernize this storage system. So regarding our media support, if a customer starts with a 2-node system, he has to choose between NVMe backend adapters and NVMe drives, or SAS backend adapters and SAS drives. With a 4-node system, he can intermix those those two kind of backend adaptators and media in the same pool. So it allows customers to choose to add, for example, nearline SAS to add capacity to the system without being without costing too much money. So we do support those intermix. And same here, the customer can choose to have NVMe backend, SAS backend, or even, for example, a diskless two-node. You can choose to have those two nodes in a diskless configuration to do some virtualization, for example, or just by simply adding CPU power to the whole systems. So today we are allowing our VSP5000 customer to upgrade the existing installation that was before a 51 or a 55 system. We are allowing them to upgrade those systems to have a brand new 56 system. So we are doing that by making a kind of controller rollout. So we are replacing one by one every controller of the system. So of course, it's done without any downtime and without shutting down the production and without introducing any single point of failure. Let's have a look to our modern storage assurance features. So we recently announced these new features for our customer. So it's an optional offering that the customer has to choose at the acquisition date of new VSP52 or 5600 systems. And what we are doing here is to ensure the customer that he will be able to do a data in place upgrade in the future during the maintenance period that the customer choose to take with the system. So, for example, if a customer bought a system with 5 years of maintenance, he will be able to ask Hitachi to do a technical refresh of the storage system anywhere between the first 12 months and the end of the support contract. And it's available with our premium support and with our standard support. So, for example, if a customer chooses to buy a VSP5600 at year 0, and if Hitachi Vantara release a new controller at year 2, for example, the customer can ask Hitachi Vantara to upgrade the controller of the existing system at year 3 and keep running his production with those new controller until the end of the original maintenance term. So, of course, this data in place upgrade is done without any performance impact, without any downtime, and without introducing any bottleneck, any single point of failure. We are doing that by making a node rollout. So in this example, you have 2 nodes for controller system. What we will do is to add another 1 node 2 controller chassis with brand new nodes, and we will power off one of the existing nodes and power on one of the new one, and so on to replace a whole node, etc. And we will replace the other one. And at the end, we will be able to replace all the base controller of the system by only new controllers. So let's talk about our Hitachi Mainframe cyber resiliency solution. So first of all, why is everybody talking about cyber resiliency today? It's quite simple, because in the traditional approach of data protection was something like that. So many customers has production server and production data. Some of them choose to add replication to be protected against any environmental threats, for example. Some of our customers choose to add a third replication to a DR site, for example, to be able to respond to a massive disaster recovery in case of an environmental issue on the production side. Many customers are spending money in a backup infrastructure, adding some backup mechanism and even some dedicated backup silos. And some customers are moving data to the cloud or on physical tape for archival purpose, for example. So what happened in case of a ransomware attack? So first, the cyber criminal will try to get information against the target, and once that's done, they will find a way by some weakness or by some human social engineering. They will find a way to infect one or many component of the infrastructure, and once that's done, they will do pretty much nothing that the customer can detect during days, weeks, or even months to really understand how all those infrastructure is working, which kind of backup is done, etc. And once that's done, they will really start the attack. So it's the spoliation and encryption phase. So the cyber criminal will first try to destruct the backup mechanism. Once that's done, they will start to encrypt or to corrupt the data. And the issue with the replication, synchronous or asynchronous, is that it will propagate very quickly the encryption or the corruption of the data. And once that's done, they will try to encrypt or to destruct the backup silos. So when we are in this situation, it's really hard to recover, and that's the moment where the cyber criminal choose to ask for a nice ransom. And the bad news for us is that currently bitcoins aren't really cheap. So what everybody is trying to do to protect those data against those cyber threats is to create really something new, is to add some protected copies that will be protected behind an air gap. And the idea in cyber security against cyber threats is to provide the customer a way to use a role separation between the people who are administrating the production solution and the people who are allowed to administrate the cyber copies of the data. So for our mainframe customer, we are providing Hitachi mainframe cyber resiliency. So it's a way to create cyber resilient copies of the production data of your production. Those copies will be stored in an open environment. So it will create an air gap because those open environments are not reachable from a mainframe perspective. We will create those copies without impacting the mainframe workload or the mainframe performances, because we know that mainframe is used for critical workload. So it will impact in case of performance issue. It may impact the business of our customers. So we choose to find a way to create those copies without having to freeze the IOs. And we are using our Ops Center suite to automate all those tasks and to help customer to analyze his environment. So how will this solution working? That's a basic example where we are implementing our mainframe cyber resiliency solution just behind the production storage system. So here you have your mainframe using a VSP5000 as a primary production system. And we are creating a clone a consistent point-in-time copy of the production data. We are creating those data here, and those data will be sent to a dedicated open formatted storage system, will be a VSP5002. And in this VSP5000 dedicated to mainframe cyber resiliency, we will create immutable snapshots. And those snapshots will be those cyber copies that we want to create behind an air gap to protect the data from any cyber attack. In case of need, the customer will be able to mount one of those snapshots through a snap and snap mechanism and make it available for some verification or forensic purpose, for example. And of course, everything will be fully automated by OpCenter Automator in this solution. So if we have a closer look to how it will work, same example here, we just implemented our cyber resiliency behind the production. So here the production data, many mainframe volumes. What we will do is to create a point-in-time consistent copy of those data, and all those volumes will be sent through our shadow image mechanism. So shadow image is our clone solution. So those volumes will be copied in this open formatted big volume, but in fact, this volume is virtualized and the capacity resides here in this open formatted system. So the data will be sent through virtualization in this open system. And once that's done, we are using our space efficient snapshot mechanism to create a protected snapshot. The OpCenter Automator mechanism will take care of creating those clone and creating those snapshots, and it will take care of deleting the old one to always keep the required number of versions. In the case, if the customers want to do some verification or some forensic, we are able to ask our OpCenter Automator system to mount one of those snapshots and make it available from a mainframe perspective to make some verification or some checks. Of course, we are using a snap and snap mechanism here to allow the customer to make an IPL on those volumes and to make some modification without modifying the original data, because in those kind of solution, we always want to protect those original snapshots, because that's our cyber resiliency copies that we will use in case of a cyber attack. So that was an example, as said before, where we implement this solution behind a single storage system. We do support implementing this mainframe cyber resiliency solution behind a PPRC primary storage system or behind an asynchronous replicated storage system in this example. And of course, we are supporting our cyber resiliency solution behind a 3DC environment, implementing this solution in this example behind the asynchronous replication. And as we are using our virtualization mechanism, we do support tailor-fitted configuration. In this example, customer choose to use his qualification storage system for the verification. So we are able to use our virtualization mechanism to make those volumes available on a different storage system, different from the production, for example. It really depends on customers' needs. And the life cycle of this solution, it's pretty simple. The good news is that in normal phase, you will have nothing to do. OpCenter Automator will take care of creating cyber resilient copies and deleting the oldest one. In case of any need of verification, the customer just had to require OpCenter to make one of the images available. And if there is any issue or any doubt regarding the data, the customer will be able to recover data from those verification volumes. So let's talk about some other features. We recently introduced what we call Hitachi Mainframe Replication extensions. So basically, it's a kind of add-on that use some data that BCM make available. So BCM, for those who doesn't know this product, it's Business Continuity Manager, and it's a software that we use on the Z side to administrate replication. So with Hitachi Mainframe Replication extension, we are using the data provided by BCM to make some real-time monitoring and alerting, and to help customer to provide some historical reports regarding the RPO of the asynchronous replication. So with this solution, our customer will have the possibility to set up two triggers. The first one is the yellow trigger. So when this first trigger in this example, it's 420 minutes. So when this first trigger is reached, an alert will be raised on the mainframe logs. So the customer will be able to be alerted that the RPO is increasing and that the RPO has reached this first trigger. Same with the second one called red alert. In this example, it's 720 minutes. So it will basically, the idea here is to help our customer to detect that the RPO is increasing and to let them time to react before any other additional issue. So we are just pushing those alerts in the mainframe log, and it's up to the customers to see how we will react. We have some news around Hitachi Mainframe Analytic Interpreter 2. So some of you may know Mainframe Analytic Recorder. It's MAR. Sorry for all those acronyms. So basically, MAR is an STC that will collect performances information directly from the storage system and pushing those performances information in the SMF repository. So it's a really good way to have time coherent information, because all the SMF records will have a timestamp that will be coherent with the other SMF records. And now, in addition of that, what we introduce is the possibility to simply extract those data from the SMF repository. Before this new feature, the customer have to use some external product like IntelliMagic or MXG, for example. But now we are able, with this new mainframe analytic interpreter, we are able to process those records in the SMF repository and to create a CSV record that will be pushed to an open storage system, to an open server to be analyzed. So it's an easy way for the customer to have detailed performance data from the storage system that has been collected by the mainframe. Some words about our synergy around the OS. So we are still working to achieve some new GDPS qualification. As you may know, we are qualified with GDPS in many configurations since years now. We recently achieved some other qualification, and you will be able to reach directly those qualifications on the IBM website. The link is in my presentation. We will, during the next months, we will introduce the support of MTMM, so for multi-target metro mirror for our VSP5000. So multi-target metro mirror is a way to have two synchronous PPRC replication from the same primary volume. So here it's called TC, but TC is for true copy. It's our Hitachi synchronous replication, but it's PPRC compatible. So we will introduce this MTMM support soon, and we will support incremental resync too. And after that, we are planning to qualify our VSP5000 for the GDPS two-leg configurations. And that's just some example, but we are still heavily investing in mainframe, and we are still developing many features to support all the new features, to support main part of the new features that are available on mainframe. A quick example about one of our partnership with some other vendors. We have many partnerships. We are working with Luminex to provide some tape solution, for example, and we are working with Model 9 with our HCP solution to provide a way to our customers to protect the data and to replace some existing parts of the tape environment by a single piece of software. And what's interesting here is that we can replace almost all the tape activity and sending all those data directly on HCP. And the interesting fact here is that with this solution, we will be able to bring immutability for tape files and for DASD files. So that's why it could be really interesting. So in case of a cyber attack, we will be able to retrieve the data on the HCP because this is our object storage solution that comes with immutability of the object stored on the HCP. And with mainframe cyber resiliency, we are able to protect the DASD data. So that's a way to protect every data of the mainframe. And that's it for me today. I don't know if there is some questions or not.
Okay, I'll allow people to unmute themselves if you have questions. So if you want to ask anything, then you can now unmute yourself and ask away. There aren't any questions in the chat window, so I'll take a moment. Okay, it looks like there aren't any questions, so it just remains for me to thank Simon very much for the presentation. I'm really pleased that Hitachi Vantara have presented, because it's good to have another perspective on the problems that there are in mainframe storage. And to look at different ways or additional ways of solving those problems. And it seems to me that whilst there are some constraints in the in providing storage for Z systems. Hitachi Vantara have also done some unique and innovative things, and it's been good to hear about those. So Simon, thank you very much indeed.
Thank you.
If there are no further questions, or if there are no questions, then I'll close the session. Last call. Okay, final reminder, please fill in the feedback forms. I think most people have heard the spiel now about the value of doing it. And again, thank you very much, Simon. Thank you.
Welcome. Thank you very much.